to the next principle of PV system design. We have learned the fundamental of solar energy. Now we're going to move on to system design. So first of all, we need to know the demand, which is the load. And then we can use that information to calculate the solar array size. Finally, I will give you some guideline about the system installation. First of all, we need to determine how much time we consume the power. Okay, so we need to know the appliance running hours per day. So we can roughly estimate that, for example, if you know you would no more watch about 4 hours of TV every day, you can use that number. To estimate the number of hours that a generator actually operates at its maximum voltage or wattage, you can divide the total time of the refrigerator is plugged in by 3. The reason for that is because refrigerators not always turn on, because it depends on the cycle on and off. We'll talk about that the following slides. Of course, you can keep a log. So, for example, you could record the cooking time, each time you use for your microwave, and work on your computer, watch your TV, or leave a light on in the room or outdoors. This example shows you the refrigerator power consumption. So the dark blue line is the power with respect to time. So for this example, the inrush power approaches 900 watts. The running power is 200 watts. So the overall average power is 73 watts. So if you divide the 70 watts by 200 watts, and you will get 37%. That means the duty cycle is around 37%. So in the previous guidelines said that you can divide the time by 3, means that the duty cycle is around 33%. And then we need to estimate the power consumption for each appliance. So you can use the following approaches. For example, you can check on the labels of the appliance. Typically, will give you the power rating. Actually, that's the maximum power rating. Or you can buy a meter to measure the voltage, current, or the wattage directly. The third method is you can use the online resources. You can check the online information to roughly estimate the power. Of course, you can always check on your electric bill, so you can have the idea of the power used in the previous years. Here's the example of appliance labels. This example shows you a hair dryer label manufactured by Taiwan company. The maximum rating here shows that it will consume 1 kilowatt of power, but actually there are 2 maximum power, depends on the heat of the air. So for example, if you want the maximum heat, the rating is 1 kilowatt. But for the heat, the air with the less heat will be consumed 500 watts. And then you can calculate the daily usage. For example, if you use 30 minutes per day and assume that the maximum power is used, then you can multiply the maximum power by 30 minutes or 0.5 hour, and the resulting energy use will be 500 watt hour per day. In the US, there's a standard called Energy Guide label. So if you read the label, it will show you some information. For example, the key feature of the appliance model, or manufacturer model number or sizes. But the most important information is the yearly operating cost and yearly electricity use. But this number is just an estimation. So the actual number will depend on how much time you use that appliance. But anyway, it will give you some guideline to do the basic estimation. You can also buy the wattage meter to do the measurement. For example, this meter will measure the instantaneous voltage, instantaneous current, and also give you the instantaneous power. And if you specify the period of time, then you will calculate the energy and also the cost. But the cost will depend on the area. This is just for your reference. The other method is use online resources. So you can check some website. For example, this website will give you a table to show you the appliance, the estimated wattage, and also some surge wattage. But of course, it's not the actual number. So if you want the more detailed information, you can check on the Energy Start website. In the US, there's an Energy Saver that belongs to US Department of Energy's consumer resource on saving energy and using renewable energy technologies at home. It provides some saver guide. It will give you some tips on saving money and energy at home. So there are information to show you how to reduce electricity use, purchase efficient products, save money on electric bills, buy or make clean electricity. So just as I mentioned, Energy Stars offers energy use information on specific products that have earned the Energy Star. So if you can purchase Energy Star appliances that actually is satisfied by the government, so that will save some more energy and also your money. So this is the typical information that you can see online. So you can choose your appliance and then go to the detail. And this is one of the examples. For example, you want to check your clothes washer for a specific brand model. And in this model, it will show you the annual energy use, which is 85 kilowatt hour per year. But this information is calculated based on annual usage of 295 loads, or around 6 loads per week. So if you wash more often or less often, then you should adjust the number. And finally, you can check on your electric bill. For example, this is my electric bill. And this blue line shows the information for this year, and the green line is the information in the previous years. And in Taiwan, we charge the power company charge us 2 months each time. So that is why we only have 6 number for each year. And then you can, based on this information, and to calculate the annual energy use. And this is the example. For example, if you can get the monthly energy use, and then you can accumulate for the 12 months altogether, then you can get the overall annual energy use. Okay, so we have the basic idea about how to determine the load or the demand. Then we are ready to size our solar array. This slide shows you the typical solar electric system. So actually this is a simplified one. First of all, we have the sunlight, and we can determine the peak sun hours from other online resources. And then we have installed some solar array, and with some peak output power. And then there are some systems, including a charger, cable, and also some inverters, etc. And finally, go to the load. And the important thing is that every equipment, including the cable, has losses. So we have to take that into account. And this slide gives you a brief review on peak sun hours. Remember that the peak sun hours is a way to measure the insolation. And it represents the available daily solar resources. And the unit is hours per day. And how to calculate that? We can actually calculate the output power generated for a day in a square meter, and then normalize that by the unit that called 1 kilowatts per square meter, and then we can get the PSH, peak sun hours. And this slide shows you the average peak sun hours in Taiwan, and you can check that from Global Solar Atlas. And for Taiwan, because the latitude, so the peak sun hours may ranging from 2.56 to 4.11 hours. So it's not quite high compared to the tropical area. How about the system loss factors? Okay, so this slide shows you a system, and that you have PV connected to some cable, and we have some charger, inverter, battery, etc. So what are the system loss factors? The first thing is it depends on manufacturer tolerance. So some solar cell may have some more losses compared to others. Temperature. In the previous lecture, we talked about the temperature will degrade the performance of the solar panel. The higher the temperature is, the lower the efficiency. dust and dirt and dust. If there are some dirt and dust on top of the panel, before, of course, the efficiency will be degraded. Cable losses due to resistance. And also the efficiency of charger controller, inverter, and battery. Finally, there may be some mismatch between a solar panel and load due to non-usage of charger controller or inverter. So have those information, then we are ready to calculate the size of the array. First of all, we can come up with this equation. We can say that the load, actually that's the demand, is equals to the peak sum hour multiplied the peak or the maximum output power of the solar array and multiplied by the loss factor. So use this equation, we can determine what's the maximum output power needed to generate from the solar panel. The equation is equals to load divided by the system loss factor times peak sum hours. And after we come out with the maximum output power, then we need to determine what kind of solar panel we are going to purchase. And then we have, if you have the maximum output power for those panels, then if you divide the overall power by the output power for each panel, then you can come up with the number. Of course, the number has to be integer. So let's use an example to do a basic calculation. So here, if we have an off-grid PV system, and then the location is in Taipei area, and then we assume that the annual average PSH is 3 hours, and the annual consumption is about 7.2 kilowatt hours. So if you divide it by 365 days per year, then you can get 19.7 kilowatt hour per day. And then you may have the peak load. The peak load means that maybe you have a lot of appliances running together. So you end up with a large power demand. So this example assumes that there are panel losses, and we assume the number is 85%. And losses from the inverter are 95%, and the battery inverter losses are 95%, and battery efficiency losses are 85%. And the cable losses in the standard testing condition is around 5%. So if you multiply all the number all together, you will end up with the overall loss is 0.62. So to cover those losses, you need to generate more powers. So we can calculate the DC power needed. We can use the previous formula. We have the daily consumption in the unit of kilowatt hour divided by the system loss factor, and then multiplied by the peak sum hour. And then finally, we can calculate the overall capacity. So in this example is 10.6 kilowatt. Actually, that's for the maximum output power. With this number, we can calculate the solar array size. So first of all, we need to know what kind of panel you are going to use. So in this example, we use the solar panel from manufactured by Jintong, and the module we choose is 280 watt. Okay, so here shows the number, and the other number is we can check out the open circuit voltage. In this case, it's 38.08 volt. And the other information is the maximum system voltage, because a lot of panel will connect in series, but this data sheet show you that the maximum voltage cannot exceed to 1000 volts. So with this information, we can calculate the number of panels. Since each panel have the 180 watts, and then the overall power needed is 10.6 kilowatts. So if you divide that by 0.28, you will get the number, which is 37.8. But remember that the number of the solar module has to be in integer. So we round up to 38 solar panels. So if you connect all of them in series, so multiply this the open circuit voltage, which is 38.08 by 38, and you will get the voltage which is higher than 1000 volts. So it cannot be connected all in series. So we can divide that into two strings in parallel, and each string will connect 19 of the panels in series. So now we have the idea of how to calculate the size of the panel. But the problem is that we have budget limit. Recall that in the previous lesson, we talked about the initial cost for the solar system, which is about 3.18 per watt. So if you have budget limit, it may not cover all the power demand. Of course, there is a space limitation. Typically, it will require 15 square meters for 3 kilowatt hour capacity. So, for example, you are going to install the system on your rooftop, then you have the space limitation. So, after you determine the energy needed annually, you need to take the budget and space into account. Okay. So we have the idea of how to calculate the load and then finally size the solar array. Before we jump into the installation, we need to know some guidelines. First of all, is the orientation and tilt angle for the array installation. azimuth is angle is the angle between the direction perpendicular to the array surface in the two nodes, which the direction along the Earth's surface toward the geographic north pole. So, for example, this array is aligned to this, facing to this southwest side. So the azimuth angle is from north to this, so you can estimate the angle. As for the tail angle, which is the angle measured between the mounted PV module and the horizontal ground surface. And this slide shows you the three scenarios. For example, if the sunlight comes from this direction, it's about 45 degrees. So if the tail angle is 90 degrees or 0 degrees, you will get less sunlight. But if you can adjust the tail angle, let the sunlight direct to the solar panel, then you will get most out of the output power. Okay, so if we are located at the north hemisphere, and you can see that in this example, the latitude for Los Angeles is 34 degrees, and it's this is the season of equinox. And you can see if sun goes up at the noontime, if you can face the solar panel to the south part, and then with the tail angle of 34 degrees, at the noontime, the sunlight will be perpendicular to the surface of solar array. That means that you can get the most power out from the system. Okay, so just as this in mind, if you are located at the north hemisphere, face to the south, the panel has to face to the south. If you are located at the southern hemisphere, then the panel has to face to north. However, there are different seasons. For example, in the summertime, the sun will higher compared to the winter time. So in summer, you should adjust the tail angle of the array, the value of the latitude, minus 15 degrees. In winter, the optimum tail angle is latitude plus 15 degrees. So for the greatest number of the hours throughout the year, mount the PV array to a tail angle equal to the local latitude. So this is considered the average case. But of course, if you want the maximum output, typically in the summertime, then you should consider the angle, which is latitude minus 15 degrees. Of course, if you have a system that can tracking the sunlight, you will get all the maximum power. But most of the time, the modules are fixed mounted. So here are some guidelines for the off-grid or standalone PV systems. The tail angle of the PV module should be determined for optimal system performance at the scariest sunlight, which is in the winter time. So it is calculated so that if the electric power output is enough upon the scarcest sunlight, the selected tilt angle is okay during the rest of the year. As for the grid tie system, it is reasonable to mount the PV array at the tilt angle, providing maximum performance in summer, as there is always less sunlight in winter. For aesthetic reasons, it is recommended that you install the PV modules at the same pitch as the roof slope. Otherwise, it becomes quite ugly. For most geographic locations, the optimal tilt angle is evaluated somewhere between latitude and latitude minus 15 degrees. So it's for the average. The ideal site for installation of PV modules. Here are some guidelines. Orientation towards the sun, of course. And lack of any sources of shading. So you have to check out the location, especially during the day and throughout the year. Shading is not recommended, at least between 9 a.m. and 3 p.m. Minimization of the length of the DC cables between the PV array and the inverter. So, for example, if you want to install the inverter in a room or in the office, then you should consider the wiring length, because the longer the cable, the larger the loss. And static. So it should become the system can be a decoration, but not the thing that change your environment. Protection from thief and vandalism. And finally, easy access for installation and maintenance of the PV array. If there is shading by nearby object, here are some practical tips. Do a survey during the bright and sunny day, preferably in summer when trees have their full foliage mass. During the site survey, look for the following obstacles. Buildings, of course, you should be informed whether a new building is not being planned nearby, throwing shadow on your site. Chimneys, power line, poles, hedges, and neighboring roofs. Trees. If you are performing your site survey in winter, remember that in summers, tree looks different than in winter. Hills and other earth obstacles. Mind that in winter, sun is much closer to the horizon than in summer. And this slide shows you how to avoid shading. Because if there is a nearby building, and assume that LS represents the distance from the Earth to Sun, which is 150 million kilometers. And D is the thickness of the shading object. It can be a tree or a building. And DS represent the diameter of the Sun, which is about 1.39 million kilometers. And you can use the mass by the ratio. So L is the distance from the shielding object to the solar array. So if you divide L by Ls, which is the ratio of these two distances, which should be equals to the thickness of the shading object divided by the diameter of the sun. And then you do the math, you can obtain the number, which means that the distance from the shading object to your solar array should be equals to 108 times D. Okay, so if you are going to install array on the rooftop, if there is a nearby trees, of course you can align the array to the angle of the rooftop. But if you want to avoid shading, then you can use the following formula to determine the angle. Okay, so if there is sunlight comes this way, and if you want this to be perpendicular to the array, and if D is the distance from the tree to your house, and delta H represent the height of the tree subtracted by the height of your house. Then use the tangent equation. Tangent theta is equals to delta H divided by D, and then you can come up with the angle, which will give you by this equation. The theta is equals to arctangent of delta H divided by D. To avoid the inter-row shading, because we have multi-rows. So for this example, we have 2 rows, and assume that the height of the PV module to the ground is H. It is recommended that the 2 individual neighborhood rows in the space that is at least 3 times the maximum height of the tiered row, so that you can avoid the inter-row shading. So finally, you have to estimate the site area. Access space around the PV module usually is up to 20% to the required area for placing them. So you need to add up around 20%. Don't try to use every last square inch on your rooftop to install a PV array because of the following reasons. The PV array gets difficult to install because there is no room. The PV array gets hard to maintain. When loading at the edge of the roof increases. And from a regulatory point of view, you could violate some provision for providing available space for the firefighters and other personnel that might need to access the roof. So this is quite important. Hope this lesson will show you how to do a basic design, and you can try that at home. That's about it. Thank you.